Okay, so the idea is to do a very short animation that describes how the Fourier transform works on signals. So the idea of Fourier transform is to take a signal and decompose it to its frequency components. So let's see how it works in a very simple example. So here I have nothing, let's say, and now I'll just add some frequencies of waves. And you see that I start with a 1 Hertz frequency wave, and you see how the wave just traveling. This is a wave that is built only from Y frequency. Now when I add another frequency, you will see that the two frequencies together build a more complex wave, as you can see right over here. Now the Fourier transform take this time domain signal and decompose it into its frequency domain and tell me what frequencies build that signal. If I add another frequency, I'll see that the signal becomes more and more complex. It is built from those three frequencies together, and I get this one. Now if I add the last one for this example, a more higher frequency, you will see that I got a wave that is built from some low frequencies and high frequencies, and together they look more complex. Now the idea of the Fourier transform is to take such complex waves and decompose them into the components that build this wave, namely taking this time domain wave and transform it into the frequency domain, where I'll get from which frequencies the wave is built, the complex wave is built from, and how much from each frequency the wave is built from. This is the idea of the decomposition of the Fourier transform. Again, just taking this complex wave that is built from different frequencies and giving me the frequency domain that show me how much from which each frequency, how much each frequency contributes to the, let's call it, the complex wave. This is the idea of the Fourier transform. That's it.